Oscilloscopes measure voltage, but what if we want to know something other than voltage? Luckily, many other parameters in a circuit can be determined mathematically if you know the voltages. Oscilloscopes usually have what are called math channels, which perform mathematical operations on the measured voltages and display the results as a function of time. This is the circuit I'll use to illustrate math channels. We're using channel 1 of the waveform generator to apply a time-varying voltage. We want to determine the current through the LED. KCL at any node tells us that the current is the same in all of the elements. The voltage across the diode is measured by channel 1 of the oscilloscope. This voltage will be used later in the video to create a voltage current characteristic for the diode. The resistor limits the current, but it also provides us with a way to calculate the current through the circuit. Ohm's law tells us that the current is just the voltage across the resistor divided by the resistance. For this 100 ohm resistor, the current will be equal to the voltage of channel 2 divided by 100. I've already set up the WaveGen instrument to create a 13 Hz triangular wave with an amplitude of 5 volts and no offset. My oscilloscope is displaying the waveform here. Now let's display the current through the 100 ohm resistor with a math channel. To create a math channel, click on the Add Channel button. There are a variety of options for math channels. We want the Custom option. This opens a custom math window. Type your equation in the text box. We want the voltage of channel 2, C2, over 100 ohms. We also want to change the units to amps. Click OK. We get a new channel control box, Math 1, and a red line on our plot window, which corresponds to the current through the resistor. That's really all there is to it. We can treat this channel the same way we do any of our others. We can set the scale and the offset. The current is a fairly small number, so let's change the range to 10 milliamps per division. To edit the math function, just click this button here. The custom math window reopens and you can change the formula. One huge reason for wanting our scope to estimate current is so that we can plot voltage and current as functions of one another. Circuit components are described by their voltage current characteristics. Next, we'll use the current channel we created to plot the voltage current characteristic for our LED. First, let's describe XY plots in general before we get to our specific application. XY plots show one measured variable as a function of another. One application for this is plotting voltage-current relationships for circuit components. In this demonstration, we'll plot the current through an LED as a function of its voltage. The resistor and the LED share the same current. So our math channel also gives us the diode current. Now we just need to generate the XY plot of the diode current as a function of the diode voltage. The diode voltage is measured by channel 1 of the oscilloscope. To create an XY plot, click on the plus XY button. An XY plot window opens. Use these menus to choose the channels to put on the X and Y axes of the plot. We want the diode voltage, channel 1, on the X-axis, and the diode current, the math channel M1, on the Y-axis. That gives us this plot, which looks about right. We can adjust the scales on the XY plot by adjusting the waveform plot scales. For example, the diode current never goes negative, so the negative Y-axis is useless. We can change the offset of our math channel to move that around. We can also rescale the math channel to, for example, 5 milliamps per division, and then move our Y-axis up. We can adjust the scale on channel 1 too. Let's change the channel 1 offset to 1 volt and change the range to 1 volt per division. The size of the XY plot window can be changed by clicking and dragging the border between the XY plot and the main plot window.